The future is pedal-powered. How e-bikes are revolutionizing urban mobility in an era where sustainability meets innovation. Electric bikes are reshaping how we move through cities. These intelligent hybrids combine traditional pedal power with cutting-edge battery technology to create a transportation solution that's both eco-friendly and efficient. From bustling metropolises to quiet suburban neighborhoods, e-bikes have become a symbol of modern mobility. They offer commuters a faster alternative to walking while eliminating the need for car ownership in many urban environments. Understanding the evolution of electric bike technology. The journey of electric bicycles began in the late 19th century with early prototypes featuring crude electrical systems. However, these initial attempts lacked the efficiency and reliability required for mainstream adoption. Modern e-bike development accelerated dramatically after lithium-ion batteries became commercially viable in the early 2000s. This breakthrough enabled lighter weight, longer range, and significantly improved performance characteristics. Battery advancements. Modern lithium-ion packs now provide up to 60 miles of range on a single charge, compared to mere miles from older lead-acid models. Motor innovations. Torque sensors and cadence sensors work together to deliver seamless power assistance without requiring constant throttle input. Smart integration has further enhanced e-bike capabilities through Bluetooth connectivity, GPS tracking, and mobile app compatibility. Riders can monitor battery levels, track routes, and receive maintenance alerts via smartphone interfaces. Recent developments include regenerative braking systems that capture kinetic energy during stops, extending overall ride duration by approximately 8 to 12%. Some high-end models even feature solar charging panels integrated into frame designs. The environmental impact of electrified cycling. E-bikes represent one of the most sustainable transportation options available today. A single e-bike produces zero tailpipe emissions while offering comparable convenience to motor vehicles. American researchers estimate that replacing 10% of car trips with e-bike rides could reduce annual CO2 emissions by over 2 million tons. This makes them particularly impactful in densely populated urban areas. Comparing carbon footprints. According to the European Cyclists Federation, producing an e-bike generates roughly one-third less carbon than manufacturing a conventional bicycle. When considering their lifespan, the environmental benefits multiply exponentially. Over 5 years of regular use, an e-bike's total emissions remain below those of a gasoline-powered moped, even when accounting for battery production and disposal processes. Cycling advocates highlight that e-bikes promote healthier lifestyles while reducing traffic congestion and parking demands. Cities adopting bike-sharing programs report significant decreases in air pollution levels within months of implementation. Performance characteristics of modern e-bikes. Contemporary e-bikes typically achieve speeds between 15 to 28 miles per hour depending on local regulations and model classifications. Most commuter-focused models operate at the lower end of this spectrum for safety reasons. Power output varies widely across different classes of e-bikes, with Class 1 models providing up to 250 W of assist and Class 3 models reaching up to 750 W. Higher wattage allows for greater hill climbing capability and speed potential. Range expectations. Average e-bikes can travel 20 to 45 miles on a full charge before needing recharging, though this depends heavily on terrain and rider effort. Weight distribution. Manufacturers carefully balance battery placement to maintain stable handling and prevent front-wheel lift under heavy acceleration. Many manufacturers incorporate torque sensors that adjust power delivery based on pedaling force rather than simply measuring crank rotation speed. Some advanced models integrate dual motor systems for superior traction control, especially beneficial in mountainous regions or wet weather conditions. Selecting the right e-bike for your needs. With numerous types of e-bikes available, choosing the right model requires careful consideration of personal requirements and riding preferences. Road e-bikes prioritize aerodynamic frames and lightweight construction for long-distance commuting purposes. Mountain e-bikes, in contrast, feature reinforced frames and suspension systems for off-road adventures. City commuters, look for foldable designs, fenders, lights, and rack mounts for carrying groceries or work gear. Mountain enthusiasts prioritize shock absorption features, wide tires, and robust disc brakes for challenging terrains. Fitness-oriented riders might prefer e-bikes with adjustable resistance settings that allow for targeted muscle training sessions combined with assisted climbs. For casual riders seeking leisurely weekend excursions, cruiser-style e-bikes offer comfortable seating positions and relaxed geometry profiles suitable for extended rides. The economic benefits of choosing an e-bike. Purchasing an e-bike represents a substantial investment upfront but offers considerable long-term savings compared to vehicle ownership costs. Monthly expenses related to fuel, insurance, registration, and maintenance add up quickly for car owners. In contrast, e-bikes require minimal ongoing expenditures once acquired. Cost comparison. An average e-bike costs $1,500 to $4,000 initially versus $30,000 plus for a new car purchase. Ongoing expenses. Charging an e-bike battery costs around 15 to 30 cents per day compared to $10 plus daily fuel costs for cars. Insurance premiums for e-bikes are generally much lower than auto insurance rates since they pose fewer risks on public roads. Additionally, many cities offer tax incentives or subsidies for residents who choose environmentally friendly transportation methods like e-biking. Safety considerations for e-bike enthusiasts. While e-bikes provide exciting mobility options, users must prioritize safety precautions to avoid accidents and ensure responsible usage. Always wear appropriate protective gear including helmets, gloves, and knee pads regardless of perceived risk level. Visibility is crucial due to increased speed compared to standard bicycles. Lighting equipment. Install front headlamps and rear tail lights to enhance visibility during low light conditions. Braking systems. Regular inspection of brake pads ensures optimal stopping distance and prevents sudden skidding incidents. Obey all traffic laws as you would with any other vehicle. Stop signs, red lights, and pedestrian crossings apply equally to e-bike operators. Never assume other drivers will yield. Always check blind spots before changing lanes or making turns. Community building through e-bike culture. The rise of e-bikes has fostered vibrant communities centered around shared experiences and mutual support among cyclists. Online forums, social media groups, and local meetups connect riders worldwide, facilitating knowledge exchange about best practices, route recommendations, and equipment reviews. Group rides. Organized events bring together enthusiasts for scenic trails, charity rides, or competitive challenges promoting camaraderie. Workshops. Many clubs host educational sessions covering topics like battery care, mechanical troubleshooting, and trail etiquette. These communities also advocate for better infrastructure improvements such as dedicated bike lanes, secure parking facilities, and safer road design elements specifically tailored for e-cyclists. Participation in such groups often leads to discovering hidden gems in local landscapes that might otherwise go unnoticed by solo travelers. Looking ahead, innovations shaping tomorrow's e-bikes. The future of electric biking promises groundbreaking technological advances set to transform our current understanding of personal transportation. Researchers are developing self-charging mechanisms utilizing piezoelectric materials embedded within tire treads that generate electricity from each pedal stroke or wheel. Revolution. Autonomous navigation. Emerging AI technologies may soon enable e-bikes equipped with smart sensors to automatically detect obstacles and optimize routing choices dynamically. Biometric integration. Advanced models could someday analyze heart rate data in real time to adjust power assistance according to individual fitness levels and exertion thresholds. Material science breakthroughs aim to produce ultra-lightweight yet durable frames using graphene composites that promise unprecedented strength-to-weight ratios. As these innovations mature, expect to see e-bikes becoming increasingly integral components of smart city infrastructures designed for seamless multimodal transport solutions. Conclusion. Electric bikes stand at the intersection of sustainability, health consciousness, and technological advancement. Their growing popularity reflects a broader societal shift toward greener living choices without compromising convenience or comfort. To fully embrace this transformative mode of transport, consider exploring your local e-bike community and staying informed about emerging trends shaping the future of urban mobility. Whether you're looking to commute smarter or explore nature responsibly, there's never been a better time to join the e-bike movement.